A stochastic process is a system that moves through states over time according to rules that include randomness. Each time the system runs, it produces one trajectory, one path through the state space. The information available at each moment is accumulated step by step. The law of the process assigns probabilities to all the possible paths it could take. The trajectory is the object of interest. The law is what governs it. The transition kernel specifies, from any current state, how likely each move is to the next state. In discrete time, this becomes a table of one-step probabilities. The kernel is the engine. It encodes the rules of motion, not the path itself. When you observe the system, the kernel does not change. When you intervene, you rewrite part of it. Those are different operations producing different futures. An absorbing state is a state that, once entered, the process cannot leave. This is built directly into the transition kernel. The probability of staying is 1, of leaving is 0. The first time the process reaches that state is the stopping time. After that point, passive observation changes nothing. The process is absorbed. No amount of conditioning on what has been seen will alter what comes next. Conditioning is a reweighting of the existing probability over paths. Intervention is a replacement of the rules that generate those paths. These are different mathematical operations. Conditioning tells you about the distribution of trajectories that satisfy some constraint. Intervention tells you about trajectories under a modified kernel. Only intervention can change what the process does next. If you condition on having survived to this point, the transition probabilities at every future step are unchanged. The Markov property guarantees this. Future behavior depends only on the current state, not on the filter. If instead you condition on a future favorable outcome, you are using information that does not yet exist. That violates the causal order. Observation does not rewrite the kernel. The system will follow its rules regardless of what you have conditioned on. Conditioning on a favorable outcome is not a strategy that produces it. It is a filter applied after the fact to trajectories that already succeeded. Intervention acts forward in time. It modifies the kernel for future transitions. Absorbing states remain absorbing under any conditioning scheme because absorption is a property of the kernel. Only a change of the kernel can change that. This distinction is structural and holds across every Markov model. Observation and manipulation are different things.